Hi everyone! In this video, we are going to be going through the Pre-Calculus A Summer Assignment, just numbers 1 through 9. Feel free to skip around through the video to see the numbers that you need help with. The directions for each of these problems is to simplify each expression. Remember that all exponents should be positive and all radicals should be simplified completely. In number 1, we want to multiply 6y squared times the quantity 2y to the 4th raised to the 3rd power. In order to complete this problem, we need to remember the two exponent rules listed on this post-it. To start, we want to simplify this expression, 2y to the 4th all raised to the 3rd power, and we want to do that by applying the 3rd power to both terms. So that term is actually going to become 2 to the 3rd power, and then y to the 4th to the 3rd power. When we simplify, we can bring down our 6y squared. Now simplifying that blue expression, that 2 to the 3rd and y to the 4th to the 3rd, 2 to the 3rd we know is just 2 times 2 times 2, which is 8. And then y to the 4th to the 3rd, we want to use this property that when we're raising a power to a power, we can multiply our exponents together. So our base stays the same as y, and our new exponent will be 4 times 3, which is 12. So now we have changed our problem to become 6y squared times 8y to the 12th. So now because everything is multiplication, we want to multiply the pieces together that we can. Starting by multiplying our numbers, 6 times 8 gives us 48. And now we want to go ahead and multiply our variables, so we have y squared and y to the 12th. To do this, we're going to be using this property. Notice we have the same base of y, so we can go ahead and add our exponents together. So our answer is going to be 48 and then y to the 2 plus 12 power, or to the 14th power. In number 2, we have the quantity negative 2x squared raised to the 3rd power multiplied by the quantity 4x cubed raised to the negative 1st power. Now remember, in the beginning, the instructions for these problems were to make sure that you end with all positive exponents. In order to do that, we need to remember this exponent rule, that a negative exponent means you're going to take that whole term and move it into the denominator. Now we're going to start this problem just like we did the last, by simplifying each term. So that means we're going to take this 3 exponent and distribute it inside our parentheses to both pieces. So I'm going to rewrite all my steps out here. So I have negative 2 to the 3rd and x squared to the 3rd. And then I'm going to do the same thing with this negative 1 and distribute it to the 4 and x cubed. So this becomes 4 to the negative 1 and x cubed to the negative 1. Now, I just want to pause for a second and take notice at how I wrote negative 2 inside parentheses. That is because this and this are actually two completely different calculations. So in this case, we get the same answer, but this is super important going throughout the rest of this year. Negative 2 to the 3rd here gives us negative 2 times negative 2 times negative 2. Whereas the order of operations in this second part would be a negative on the outside, or a negative 1 times 2 to the 3rd. So when you have an odd power like this, your answer ends up being the same, but if we were to have an even power, then your answers would have opposite signs. So just be really careful with this moving forward throughout the year. So negative 2 to the 3rd would be negative 2 times negative 2 times negative 2, which gives us negative 8. And then just like our exponent rules in number 1, we have x squared raised to the 3rd. We can go ahead and multiply those together. So we get x to the 6th times. Then we have 4 to the negative 1st power. So using our exponent rules, I'm actually going to write that as 1 over, and that would be 4 to the 1st power, which we can also just write as 1 over 4. And then we have x cubed raised to the negative 1st power. So this is very similar to this part back here, where we can go ahead and just multiply those two together. And I'm going to write this as x to the negative 3. So I still have a negative exponent, and if this was my final answer, I would want to change that. But because I'm still completing calculations, it might be easier to leave it and work with our negative exponent. Just like in number 1, now that I have all multiplication, I can go ahead and simplify. So I'm going to start by multiplying my coefficients together. Negative 8 times 1/4 would give us negative 2. And then I want to multiply together x to the 6th and x to the negative 3rd. So when I do that, x to the 6 times x to the negative third, same base means I can go ahead and add my exponents. 6 plus negative 3 would just give us x to the positive third power. Okay, for number 3, we want to simplify 6 times the square root of 3 over the square root of 8. Now, right off the bat, I notice that the square root of 8 is something that I can reduce. So we want to quickly recall that the square root of 8 we can also write as the square root of 4 times 2. The square root of 4 we know is just 2, and then we still have that 2 on the inside. So I'm going to rewrite my problem as 6 square root of 3 over 2 square root of 2, so I just replace square root of 8 with 2 root 2. Now I notice that this 6 over 2 is a fraction that I can easily reduce, or I can do that division. 6 divided by 2 just gives us 3, and then we still have that root 3 over root 2. Now we know it's a big problem and we're not allowed to leave our radicals in the denominator, so in order to finish this problem, we want to go ahead and rationalize. Now we can rationalize by multiplying by a representative of 1. In this case, that's going to be the square root of 2 over the square root of 2. So because it's something over itself, we know that that number is equal to 1, meaning it's not changing our problem, but it's going to help us get rid of that radical in the denominator. So multiplying straight across, we have 3 times the square root of 3 times the square root of 2. Remember, you can multiply inside your radicals just like we did over here. So this gives us the square root of 6 over the square root of 2 times the square root of 2 is the square root of 4, but we know the square root of 4 is just 2, so we can go ahead and finalize our answer as 3 square root of 6 over 2. Okay, looking at number 4, very similar. There's nothing to reduce, but again, the problem here is that we have a radical in the denominator. So in order to help us, we need to rationalize again, just like we did in number 3. But looking at our denominator, we have that whole quantity 5 minus root 3. So if we were to multiply a root 3 through the denominator, we would have to distribute and we would still have a radical in the denominator. So this is where we have to use something called the conjugate. So we need to rationalize again by multiplying by a representative of 1, but this time it's going to actually be a binomial. So we're going to keep this 5 minus square root of 3, except for we're going to choose the opposite sign, that 5 plus root 3. And what we're actually creating here is a difference of squares pattern. So again, because I have something divided by itself, that number is just 1. I'm not changing my problem. But now I can go ahead and multiply. In the numerator, I'm going to just distribute my 2 to both pieces. So my numerator becomes 2 times 5 is just 10 plus 2 square roots of 3. Now in my denominator, like I said, we're creating a difference of squares pattern. I'm going to go through the whole FOILing process to multiply these out so that we see what happens, but this is a place where if you know this pattern, you'd be welcome to jump. So here, remember, multiplying binomial times binomial, we want to go ahead and FOIL. So I'm going to start by multiplying 5 times 5, and I will get 25. Now I want to multiply my outside numbers, so 5 times positive root 3 gives me a plus 5 root 3. My inside numbers are a negative root 3 times 5, so that gives me a minus 5 root 3. And then finally, I have negative root 3 and positive root 3, which gives me a negative square root of 9. Now there's a lot of simplification that I can do in that denominator. So I'm going to keep my numerator as 10 plus 2 root 3. Denominator, I'm going to leave my 25. But then I'll notice that I have a positive root 3 and a positive 5 root 3 and a negative 5 root 3. So that ends up equaling 0, so those are gone. And then the square root of 9 we know is just 3, so I can actually just write minus 3. And then finally, I now just have a regular subtraction problem in my denominator, so I can write my final answer here as 10 plus 2 root 3 over 25 minus 3 is just 22. Oh, a bit more here. Notice I have all even numbers, so I can take a 2 out. So if I write this as 2, and then 5 plus root 3 over, I'm going to write 22 as 2 times 11. Notice that my 2's cancel. So our final answer here would be 5 plus the square root of 3 over 11. Okay, in number 5, we want to multiply negative 4x times the quantity 1/8 x plus 3. So because we have our multiplication on the outside, we're going to want to distribute this whole negative 4x to both terms. So first we're going to have negative 4x times 1/8 x. So we're going to start by multiplying those coefficients. Negative 4 times 1/8 would give us negative 4 over 8, which would give us negative 1/2. And then we have our x's, and because there's no exponent written, we know that that exponent is really just a 1. So going back to those exponent rules, we would have x to the 1 plus 1, or x squared, plus, now when we multiply negative 4x times 3, we can multiply our coefficients. Negative 4 times 3 gives us negative 12. And then x to the first, and then since there's no variable, we just keep that x. So we can finally write this as negative 1/2 x squared minus 12x. Okay, looking at number 6, we have negative 4 times the square root of 15 multiplied by the square root of 3. We need to combine these square roots. Starting out and looking at it, there's nothing I can really reduce here. So we're going to start just with negative 4, and then I'm going to simplify my square roots as 15 times 3 all inside one square root, which I can then write as negative 4 square root of 15 times 3 is just 45. So now I want to think about multiples of 45, and I'm looking for one that has a perfect square in it. So I can now take that 45 and actually break it down into the square root of 9 times 5, because I know that the square root of 9 as a perfect square is just 3. So this gives us negative 4 times 3, and then we still have the square root of 5 on the inside. And now I can just multiply my coefficients together. So I have negative 4 times 3 is negative 12, and then we still have the square root of 5. Okay, looking at number 7, it looks very similar to number 6, just a little bit more complex. Here we want to multiply negative 3 square root of 7y cubed times 6 square root of 7y squared. So we're going to start by, since we have multiplication all the way through, I'm going to go ahead and multiply my coefficients and then combine my radicals. So my coefficients, negative 3 times 6, I have negative 18 all the way on the outside. Then I'm just going to combine everything into one square root. So I have the square root of 7 times 7 would give me 49. And then y cubed times y squared, just like in those very beginning problems, the same base, we can add those exponents to be y to the 5th. Now from here, I want to go ahead and simplify anything that I can. The first thing I notice, square root of 49, I know is just 7. So I'm going to write this as negative 18 times 7, and then I have the square root of y to the 5th. Now, negative 18 times 7 is just negative 126, and then we still have that square root of y to the 5th, but I'm going to actually break that down into the square root of y to the 4th times y. There's a couple ways of thinking about this. So you might know that y to the 4th you can pull out would be y squared times y squared, but we could also take it and remember how we can convert our radicals into rational exponents. So I'm going to go through those steps. You wouldn't have to write them down if you recognize that in your head, but remember that I can write this y, square root of y to the 4th. I can convert, since my index here is 2, I can write this as y to the 4 over 2, which reduces to y squared. So if you're ever unsure, you can go ahead and rewrite your radicals as a rational exponent to see if they break down. So that means I can pull this out of my radical. So my final answer here would be negative 126, replacing that square root of y to the 4th with a y squared. And then we still have this square root of y on the inside. Okay, in number 8, we are adding and subtracting radicals. We have the square root of 50 plus the square root of 18 minus the square root of 8. Now remember, you can only add or subtract like terms, and in this case, a like term would be a radical with the same index, which here is 2, and then the same number on the inside as well. So before we do anything, we're actually going to go ahead and simplify all of these radicals. So I'm going to break them down one by one. And I'm going to go through the steps. Again, if you don't need to go through the steps, that is totally fine. Feel free to jump ahead. So here, the square root of 50, I'm going to write as the square root of 25 times 2, choosing 25 because that is a perfect square. And I know that the square root of 25 is just 5, and I still have a root 2. Then I'm going to go ahead and simplify the square root of 18. Again, I'm going to break that into the square root of 9 times 2. Choosing 9 because 9 is a perfect square, and I know I can replace that with a 3, and then I still have root 2. I didn't change any signs, so I can keep my plus. And then the square root of 8, I'm going to rewrite as the square root of 4 times 2, again because I know that I can simplify the square root of 4 into a 2, and then I still have that root 2. Didn't change any signs, so bringing my minus down. So I've rewritten, just by simplifying, I've rewritten this problem to say 5 radical 2 plus 3 radical 2 minus 2 radical 2. And in this case, that radical 2 is like the quantity. So now I can go ahead and add and subtract left to right, combining like terms. So if I have 5 radical 2 plus 3 radical 2, remember now I'm just dealing with those coefficients. 5 plus 3 is just 8 radical 2, and then I still have minus 2 radical 2. And then finally, left to right, 8 radical 2 minus 2 radical 2, subtracting 8 minus 2 just gives us 6, and we still have that radical 2. Okay, for number 9, we want to multiply the quantity 6 minus 3 radical 2 times the quantity 4 plus radical 5. Notice the post-it. To multiply a binomial by a binomial, we need to distribute each term, or as some of you may have learned it, FOIL. So we're going to go through distributing each. I'm going to write out all of the steps. So here we're going to multiply our first terms together, 6 times 4. And 6 times 4 we know is 24. Now we're going to distribute our 6 all the way to our outside term. So 6 times positive radical 5 we can write as positive 6 radical 5. Now we're going to multiply our inside terms, or we're going to start distributing our negative 3 radical 2, and it's important that we keep that sign with it. And we're going to multiply our negative 3 radical 2 times 4. So let's think, negative 3 radical 2 times 4. We're going to multiply our coefficients together, which would mean this negative 3 and 4, which would give us negative 12, and then we still have that radical 2. And then finally, we want to distribute this negative 3 radical 2 all the way to the radical 5. So now we have negative 3 radical 2 times radical 5. Now, last time we distributed our coefficients, or we multiplied our coefficients, here the coefficient in our second term is just a 1. So we would have negative 3 times positive 1 gives us negative 3. But now we want to combine our radical 2 and our radical 5, which we can write as the square root of 10. We just want to go ahead and check that there's nothing that we can combine or simplify, and there's not, so we can leave this as our final answer. Great job! Feel free to reach out to your teacher with any additional questions.